Download this code from codegive.com, link in the description below. Are your tests slowing you down? A deep dive with Trisha G's insights. Trisha G's talks and writings often highlight the importance of fast and effective tests. Tests are crucial for confidence, reliability, and maintainability of your code. However, slow tests can be a significant bottleneck, hindering development velocity, discouraging frequent execution, and even leading to code quality degradation as developers avoid writing tests to get things done. This tutorial will explore common reasons why tests slow down, and provide practical advice, inspired by Trisha G's approach, along with code examples, to identify, diagnose, and remediate slow tests. We'll cover 1. The high cost of slow tests * understanding the impact. 2. Identifying the culprits * methods for detecting slow tests. 3. Common causes and solutions *. External dependencies, databases, APIs, etc. Large data sets and setup overhead. Excessive use of end-to-end, E2E, tests. Algorithm inefficiency in tests. Poor test design. 4 strategies for faster tests *. Unit testing focus * isolating and testing small units of code. Mocking and stubbing * replacing external dependencies. In-memory databases * using lightweight databases for tests. Parallel test execution * running tests concurrently. Optimizing test data setup * efficiently preparing test data. Profiling and performance tuning * identifying and fixing bottlenecks. 5. Test pyramid and test automation strategy * balancing different test types. 6. Continuous monitoring and improvement * keeping tests fast over time. 1. The high cost of slow tests *. Slow tests impact development in numerous ways. Reduce development velocity * developers spend more time waiting for tests to complete, slowing down the feedback loop and reducing productivity. Infrequent test execution * developers become less likely to run tests frequently, leading to increased risk of introducing bugs. Lower confidence * slow tests can discourage developers from refactoring or making changes, as they fear the impact on the already slow test suite. Increased technical debt * a reluctance to add tests to existing code to avoid slowing the suite further contributes to technical debt. Discourage TDD/BDD * test-driven development, TDD, and behavior-driven development, BDD, heavily rely on rapid test feedback. Slow tests make these practices difficult to adopt. Delayed releases * long test execution times can delay the release process, as teams need to spend more time verifying the software. Higher costs * more developer time is spent waiting for tests, translating to higher project costs. Trisha G emphasizes that fast tests are not just about speed, they are about enabling a faster and more confident development cycle. 2. Identifying the culprits ***. The first step is to identify which tests are slow. Manual observation * simply observing the execution time of different tests can reveal the worst offenders. Most testing frameworks display execution times. Test reporting tools * many CI/CD tools, Jenkins, GitLab CI, Circle CI, etc., provide detailed test reports, including execution times for each test. Custom logging * add timestamps around your tests to measure execution time programmatically and log the results. Here's a simple example using JUnit. This code logs the duration of each test to the console. You can customize this to write to a file or integrate with a more sophisticated monitoring system. 3. Common causes and solutions ***. Here's a breakdown of common causes for slow tests and how to address them. *A. External dependencies, databases, APIs, etc. Problem * interacting with external systems, databases, APIs, message queues, adds significant overhead to tests due to network latency, database operations, and potential throttling. Solutions ***. Mocking and stubbing ** replace external dependencies with mock objects or stubs that simulate their behavior without actually interacting with the real systems. Mocking * create objects that verify interactions, ensuring that the system under test calls the dependency correctly. Stubbing * provide pre-programmed responses to specific method calls, allowing you to control the dependency's behavior and avoid external calls. Example, using Mockito. In this example, we use Mockito to create a mock data service. The when method stubs the getData method, and the verify method confirms that the mock was called as expected. This allows us to test data processor in isolation, without relying on a real data service. In-memory databases use an in-memory database, example H2, embedded Derby, for tests instead of a real database. These databases are much faster and easier to set up. Example, using H2. This example uses H2 to create an in-memory database, create a table, insert data, query data, and assert the result. All of this happens within the test, without requiring a separate database server. Containerization. Test containers use test containers to spin up lightweight containers for databases or other external dependencies. This allows you to test against a real environment without the overhead of manual setup. Caching. Cache responses from external APIs to avoid redundant calls during tests. This is useful when the data doesn't change frequently. B. Large data sets and setup overhead. Problem * creating large data sets for tests can be time-consuming. Complex setup procedures involving multiple steps can also contribute to slow test execution. Solutions ***. Data factories and builders * use data factories or builders to generate test data efficiently. This avoids repetitive code and makes it easier to create variations of data. Example, using a simple data factory. This example shows a simple user factory that creates user objects with default values. You can easily customize the factory to create different types of users or generate specific data. Shared test data create a shared set of test data that can be reused across multiple tests. This avoids duplicating the data setup process. Lazy initialization initialize test data only when it is needed. This can reduce the overall setup time if some data is not used in every test. Transactions and rollbacks wrap database operations in transactions and roll them back after each test to restore the database to its original state. This avoids the need to recreate the database for each test. Each test in this example runs within its own transaction, which is rolled back after the test completes. This ensures that the database is in a clean state before each test. See excessive use of end-to-end, E2E, tests. Problem E2E tests simulate user interactions with the entire system, which often involve multiple components and external dependencies. They are inherently slow and brittle. Solutions Reduce E2E test coverage Focus E2E tests on critical user flows and prioritize unit and integration tests for other aspects of the system. Optimize E2E tests. Minimize the number of steps in each E2E test and optimize the locators used to interact with the UI. Parallel E2E test execution. Run E2E tests concurrently to reduce the overall execution time. Requires infrastructure and careful consideration of shared resources. Use headless browsers. Run E2E tests in headless browsers, example Chrome headless, Puppeteer, to avoid the overhead of displaying the UI. Mock external services. If E2E tests interact with external services, consider mocking them to avoid network latency. D. Algorithm inefficiency in tests. Problem. Tests can sometimes contain inefficient algorithms that significantly slow down execution. This is particularly true if the test involves complex data processing or calculations. Solutions. Review test logic. Carefully review the logic of your tests to identify any inefficient algorithms. Optimize algorithms. Replace inefficient algorithms with more efficient ones. Consider using appropriate data structures, example hash tables instead of lists for lookups. Profile test execution. Use profiling tools to identify the bottlenecks in your tests. Example. While both tests functionally achieve the same thing, the test-efficient search will be much faster for large data sets. The contains method on a list may use optimizations like binary search, while the first test performs a linear search. The exact implementation will depend on the specific list implementation being used. Poor test design. Problem. Poorly designed tests can be complex, difficult to understand, and slow to execute. Solutions. Keep tests focused. Each test should focus on a single aspect of the system's behavior. Avoid writing tests that try to do too much. Use descriptive names. Give your tests descriptive names that clearly indicate what they are testing. Follow the AAA pattern, arrange, act, assert. Structure your tests according to the arrange act assert pattern to improve readability and maintainability. Avoid code duplication. Refactor common test code into reusable methods or helper classes. Write maintainable tests. Make sure your tests are easy to understand and modify. 4. Strategies for faster tests. Building on the solutions above, here are some general strategies for faster tests. A. Unit testing focus. Prioritize unit tests, which are fast and easy to write. Unit tests should cover the majority of your code. Trisha G. often advocates for a strong emphasis on unit testing, covering all critical logic in isolation. B. Mocking and stubbing. Use mocking and stubbing extensively to isolate units of code and avoid external dependencies. C. In-memory databases. Use in-memory databases for integration tests that require database interaction. D. Parallel test execution. Run tests concurrently to reduce the overall execution time. Most testing frameworks and CI/CD tools support parallel test execution. Example, JUnit 5 parallel execution. You also need to configure JUnit to enable concurrent test execution. This typically involves setting the junit.jupyter.execution.parallel.enabled property to true and configuring the number of threads. E. Optimizing test data setup. Use data factories, shared test data, and lazy initialization to minimize the time spent setting up test data. F. Profiling and performance tuning. Use profiling tools to identify the bottlenecks in your tests and optimize their performance. Java profilers like Visual VM or JProfiler can help pinpoint slow methods and memory issues. 5. Test pyramid and test automation strategy ****. Trisha G emphasizes the importance of the test pyramid. The test pyramid is a useful visual representation of a recommended test strategy. Base, large unit tests. The largest layer, focusing on isolating and testing individual components or units of code. These should be numerous, fast, and independent. Middle, medium integration tests. Tests that verify the interaction between multiple units or components. They are more complex than unit tests but still relatively fast. Top, small end-to-end tests. The smallest layer, simulating user interactions with the entire system. These are the slowest and most brittle tests, so they should be used sparingly and focused on critical user flows. The key is to have a solid base of unit tests, a reasonable number of integration tests, and a minimal number of E2E tests. 6. Continuous monitoring and improvement. Keeping your tests fast is an ongoing process. Monitor test execution times. Track the execution times of your tests over time to identify performance regressions. Use CI/CD tools to automatically collect and report test execution data. Regularly review and refactor tests. Refactor your tests to improve their performance and maintainability. Address slow tests promptly. When you identify a slow test, investigate the cause and implement a solution. Don't let slow tests linger. Integrate performance testing. Consider incorporating performance tests into your CI/CD pipeline to identify performance issues early in the development process. Conclusion. Slow tests can have a detrimental impact on development velocity and code quality. By understanding the common causes of slow tests and implementing the strategies outlined in this tutorial, you can significantly improve the performance of your test suite and enable a faster, more confident, and more enjoyable development experience. Trisha G's advice boils down to focusing on unit tests, minimizing external dependencies, and continuously monitoring and optimizing your tests. Remember, fast tests are an investment that pays off in the long run. Okay, let's dive into Trisha G's insightful talk, Are Your Tests Slowing You Down?, and explore how to identify, understand, and address slow test suites. This will be a comprehensive guide, incorporating concepts from the talk, practical code examples, and actionable steps. The problem, the silent drag of slow tests. The core message ***. The central thesis of Trisha G's talk is that slow tests are more than just an inconvenience. They subtly erode your development workflow, leading to reduced developer productivity. Developers are less likely to run tests frequently if they take a long time. This means less frequent feedback, more integration issues, and a greater risk of introducing bugs. Increased debugging time. When problems do arise, isolating the root cause becomes more difficult when you haven't been running tests often. Reluctance to write new tests. Developers may resist adding new tests if they know it will further increase the execution time of the test suite. This results in lower code coverage and increased technical debt. Decreased confidence in the code base. If developers are unsure whether changes will break existing functionality due to infrequent testing, they lose confidence in the reliability of the code. Broken feedback loop. The fundamental benefit of automated testing is a rapid feedback loop. Slow tests break this loop, making development a much slower and less iterative process. CI/CD bottleneck. Slow test suites become a major bottleneck in continuous integration and continuous delivery pipelines. Long build times delay releases and increase the time it takes to get code into production. The hidden costs asterisk asterisk. The insidious part is that these effects are often gradual and hard to quantify. You might not immediately realize that your test suite slowness is costing you significant time and money. 2. Identifying and measuring slow tests. A. Profiling and instrumentation asterisk. Asterisk. The importance of measurement asterisk. You can't fix what you can't measure. The first step is to identify which tests are taking the longest. Asterisk. Tools and techniques asterisk. Asterisk. IDE profiling asterisk. Most IDEs, IntelliJ IDEA, Eclipse, VS Code, have built-in profilers that can help you identify slow methods and code paths within your tests. Asterisk. Test runners with timing information asterisk. Modern test runners provide timing information for each test case. Pay attention to the slowest tests report. Examples. Asterisk. JUnit asterisk. JUnit can be configured to report the execution time of each test. Use @timeout annotation when specific tests should be run only with the limited time. Asterisk. TestNG asterisk. TestNG also offers detailed timing reports. Asterisk. Gradle and Maven asterisk. Build tools like Gradle and Maven provide tasks that execute tests and report execution times. Asterisk. Custom timing asterisk. You can add your own timing code to measure specific parts of your tests. B code example, JUnit with timing. Explanation asterisk. Asterisk. At before each, executed before each test method. Asterisk. At after each, executed after each test method. Asterisk. The start timer and stop timer methods measure the execution time of each test and print it to the console. You can redirect this output to a file or log it to a central monitoring system. See identifying patterns asterisk. Once you have timing data, look for patterns. Asterisk. Which test classes are consistently slow? Asterisk. Which individual tests are the slowest? Asterisk. Are there specific database calls, network requests, or file system operations that are causing the slowdown? Asterisk. Are there tests with unnecessary setup or teardown? Asterisk. Are some tests doing way more than what is required? Asterisk. Are there any tests that run for several minutes without any particular reason? 3. Common causes of slow tests and solutions. Trisha G identifies several common culprits. A. Database interactions asterisk. Asterisk. Problem asterisk. Database operations are often a major source of slowness. Starting/stopping databases, loading large data sets, and executing complex queries are all time-consuming. Asterisk. Solutions asterisk. 1. In-memory databases, example H2, SQLite. Replace your production database with an in-memory database for testing. This eliminates network latency and disk I/O. 2. Mocking database interactions asterisk. Use mocking frameworks, Mockito, EasyMock, PowerMock, to replace your database access layer with simulated responses. This allows you to test your code without actually interacting with a database. Explanation asterisk. Asterisk. We mock the user.io interface, which represents the database access layer. Asterisk. We use Mockito.when to define the behavior of the mock when get username by ID 1 is called. Asterisk. We verify that the mock was called using Mockito.verify. Asterisk. This allows us to test the user service without actually hitting the database. 3. Transaction management asterisk. Ensure that your tests are properly rolling back transactions after each test to avoid polluting the database. Use @transactional annotation in Spring or similar mechanisms in other frameworks. 4. Connection pooling asterisk. Ensure you are using connection pooling to avoid the overhead of creating and closing database connections for each test. 5. Data set management asterisk. Flyway or Liquibase use database migration tools to manage the schema and seed data for your test database. Dedicated test data create a dedicated set of test data that is small and focused on the specific scenarios you need to test. Database seeding use database seeding tools or scripts to populate your test database with data quickly. External service dependencies problem calling external services, REST APIs, message queues, etc. during tests can introduce significant latency and make your tests unreliable. Solutions 1. Mocking external services use mocking frameworks, wire mock server, to simulate external service responses. This allows you to control the behavior of the external service and test your code in isolation. Explanation We start a wire mock server on localhost 8080. We use stub for to define a mock response for the /API/data endpoint. We make a request to the mock service using HTTP client. We assert that the response is what we expect. We use verify to ensure that the request was made to the mock service. 2. Service virtualization similar to mocking, but provides a more realistic simulation of the external service. 3. Stubs create simple in-memory stubs for external services. 4. Offline testing design your code to be testable offline, without requiring access to external services. This might involve using configuration flags or dependency injection. See complex setup and teardown problem tests that require extensive setup or teardown can be slow. This is especially true if the setup and teardown are redundant across multiple tests. Solutions 1. Shared fixtures use shared fixtures, example at before all, at after all in JUnit 5, at before class, at after class in JUnit 4, to perform setup and teardown operations that are common to multiple tests. Be very careful of state in these methods. 2. Test doubles, mocks, stubs, fakes use test doubles to replace complex dependencies with simpler, faster implementations. 3. Database rollback use database transactions and rollback after each test to avoid polluting the database. 4. Object mother pattern create helper classes that encapsulate the creation of complex objects, making your tests more readable and maintainable. Excessive assertions problem tests that make too many assertions can be slow and difficult to debug. It's better to have many small, focused tests than a few large, complex ones. Solutions 1. Focus on a single behavior each test should focus on verifying a single behavior of the code. 2. Arrange act assert pattern follow the arrange act assert pattern to make your tests more readable and maintainable. 3. Avoid God classes / methods design your code to be modular and cohesive, so that tests can be small and focused. Timeouts problem tests that can get stuck in infinite loops or deadlocks can significantly slow down your test suite. Solutions 1. At timeout annotation use the at timeout annotation, or equivalent in other frameworks, to set a maximum execution time for each test. This will prevent tests from running indefinitely. 2. Defensive programming write code that is resilient to errors and unexpected conditions. Use try-catch blocks and logging to help identify and diagnose problems. 3. Thread dumps if you suspect that a test is stuck in a deadlock or infinite loop, use a thread dump to analyze the state of the threads. Sleeping / waiting problem use of thread.sleep, or other explicit wait mechanisms can introduce significant delays in your test suite. Asterisk solutions asterisk. 1. Avoid explicit thread. Sleep, asterisk replace it with more robust synchronization techniques such as countdown latch, cyclic barrier, or completable future. 2. Polling with a timeout asterisk if you absolutely must wait for a condition to become true, use a polling mechanism with a timeout. 3. Mocking asynchronous operations asterisk for asynchronous operations, mock the asynchronous components to control the timing of events. 4. Optimizing test execution. A parallel test execution asterisk. Asterisk concept asterisk run tests in parallel to utilize multiple CPU cores and reduce the overall test execution time. Asterisk tools and techniques asterisk. Asterisk JUnit parallel execution asterisk configure JUnit to run tests in parallel. Asterisk test-ng parallel execution asterisk test-ng also supports parallel test execution. Asterisk Gradle and Maven asterisk configure your build tool to run tests in parallel. Important considerations for parallel testing asterisk. Asterisk thread safety asterisk ensure that your code is thread safe. Shared resources, example databases, files, must be properly synchronized to avoid race conditions. Asterisk test isolation asterisk tests should be isolated from each other. Avoid shared state between tests, as this can lead to unexpected behavior when tests are run in parallel. Asterisk configuration asterisk configure the number of threads to use for parallel execution. The optimal number of threads will depend on the number of CPU cores and the nature of your tests. Asterisk data race asterisk if tests have access to shared mutable state, a data race could happen. B. Selective test execution asterisk. Asterisk concept asterisk run only the tests that are relevant to the changes you've made. This can significantly reduce the test execution time during development. Asterisk tools and techniques asterisk. Asterisk IDE test runners asterisk most IDEs allow you to run individual tests, test classes, or test suites. Asterisk Git integration asterisk use Git to identify the files that have been changed and run only the tests that cover those files. Asterisk code coverage tools asterisk use code coverage tools to identify which tests cover specific lines of code. Asterisk impact analysis asterisk use tools that analyze the dependencies between tests and code to determine which tests are affected by a change. Asterisk Maven plugin asterisk. MVN test equals my test class. C continuous integration asterisk. Asterisk concept asterisk automate the build, test, and deployment process to ensure that code changes are integrated frequently and reliably. Asterisk tools asterisk. Asterisk Jenkins asterisk a popular open source CI/CD server. Asterisk GitHub Actions asterisk a CI/CD service integrated with GitHub. Asterisk GitLab CI/CD asterisk a CI/CD service integrated with GitLab. Asterisk Circle CI asterisk a cloud-based CI/CD platform. Asterisk Azure DevOps asterisk a CI/CD service from Microsoft. Asterisk optimizations in CI asterisk. Asterisk caching asterisk cache dependencies and build artifacts to speed up subsequent builds. Asterisk Docker asterisk use Docker containers to ensure consistent build environments. Asterisk parallel execution asterisk run tests in parallel on the CI server. Asterisk test sharding asterisk divide the test suite into smaller shards and run them in parallel across multiple agents. D test pyramid and test types asterisk. Asterisk concept asterisk follow the test pyramid to ensure that you have the right balance of different types of tests. Asterisk test types asterisk. Asterisk unit tests asterisk test individual units of code in isolation. Asterisk integration tests asterisk test the interactions between different units of code. End-to-end tests test the entire system from end to end. The test pyramid suggests many unit tests these should be fast and focused. Fewer integration tests these are slower than unit tests but verify that different parts of the system work together. Very few end-to-end tests these are the slowest and most brittle tests. They should only cover the most critical user flows. Key takeaways. Slow tests are a hidden cost. They erode productivity, increase debugging time, and reduce confidence in the code base. Measure and profile your tests. Identify the slowest tests and the root causes of the slowness. Address common culprits. Database interactions, external service dependencies, complex setup/teardown, and excessive assertions. Optimize test execution. Use parallel test execution, selective test execution, and continuous integration. Follow the test pyramid. Ensure that you have the right balance of different types of tests. Invest in test automation. The time and effort you spend optimizing your tests will pay off in the long run. Continuous improvement. Regularly review the performance of your test suite and look for opportunities to optimize it. 6. Additional tips and best practices. Keep tests small and focused. Each test should focus on a single aspect of the code's behavior. Use meaningful test names. Give your tests descriptive names that clearly indicate what they are testing. Write clean test code. Use clear and concise code in your tests to make them easy to understand and maintain. Refactor tests regularly. Just like production code, tests should be refactored to improve their readability and maintainability. Collaborate with developers. Work with developers to identify and address slow tests. Use code coverage metrics. Use code coverage tools to identify areas of the code that are not covered by tests. Monitor test execution times. Track the execution times of your tests over time to identify performance regressions. Set performance budgets. Set performance budgets for your tests to ensure that they remain fast. By following these guidelines, you can create a test suite that is fast, reliable, and effective at catching bugs. This will lead to increased developer productivity, higher quality code, and faster time to market. Remember, the journey of optimizing your tests is an ongoing process. Embrace continuous improvement and adapt your strategies as your project evolves.